Yeah, welcome to Bawashli Electric. Once more, this is part 2 of our reverse and forward 3-phase motor control. So today we are going to look at the rear wiring. Those who didn't see part 1, it was all about circuit wiring. You can check out the link in the description below and come at a consensus and be at the same level with us. So today we are going to look at the rear wiring. And without wastage of time, allow me to continue. Once more, I'm using CAD simulation software. Any simulation software you use, it is all up to you. What we need is the basics. So I'm going to have a power supply as usual, line 1, line 2, line 3, and a neutral. I'm going to have a rear circuit breaker, then I'm going to have 2 contactors, one for clockwise and another one for anti-clockwise. Where is it? Yeah, so then I'm going to add overload for control, for protection. Then of course we are now going to have the rear motor. That is what we are going to wire today. So allow me arrange our components very well. Yes, then we have a motor somewhere here and an overload. Somewhere there. So let's have our cables drawn. So this is the power circuit, the power line. So that is for clockwise. Now we are going to draw for anti-clockwise. So we are going to maintain line 2. We are going to maintain line 2. Hope we see it from line 2 to line 2. Then we are going to interchange for this circuit. Remember I told you for reverse and forward you interchange any 2 lines. It will give you a reverse direction. We are going to interchange 1 and 3. So with 1 we are going to give it 3. Then it's coming here to 3. I see. Then with the 3 we are going to give it 1. You see, it's coming here to 1. It looks like not interchange, but is interchanged. When you follow here, line 1, it's finishing with line 3. Here, line 2 is finishing with line 2, it is constant. Then here, line 3 is finishing up with line 1. So that one is the anti-clockwise direction. We are going to route the neutral also. For that one, for now, it's going to stop there. So that is our power line. What is remaining? It is the control line. So with the control, let's have here, we are going to start with the buttons. We have a button to act as an emergency. I have one to act as a stop. I have the other one to act as the 4 clockwise. I have the anti-clockwise button. So I'm going to configure these ones. This one is emergency. Then this one I'm going to configure it and give it a stop. Yeah, then the rest shall remain the way they are. I would love to start with a control breaker. Unfortunately, this software of mine doesn't have a 2-pole breaker or a 1-pole breaker. For that case, therefore, I'm going to use the main breaker just also to provide us with control power. So let's do the connections and we see. So we are going to have the control power. When I start the cabling, I'm going to get a live wire. I'm just going to pick from one line of the main breaker. Then I'm going to drive it to my emergency. Through 1 and 2. Now it is 1 and 2 which is normally closed. 3 and 4 is normally open. And here we use the normally closed line as it was in the circuit diagram. So from the emergency to the stop button, still we use the normally closed line. Now when it comes to the start button, we use a normally open. Here we use a normally open line to start. Then we shall give the same power to our friend of the anti-clockwise. Also we use the normally open line which is 3 and 4. Just like that. Then from these normally open buttons to their respective contactors. This is for clockwise, this is for clockwise. This one anti-clockwise, this one anti-clockwise. So we are going to give their A1 terminals. We are going to first do the interlocking, whereby this button, it powers this contactor, but before it reaches this coil, it has to pass through the normally closed of this one, as well as this one powers this contactor, but has first passed through the normally closed of this one. So, and the normally closed line is the, when I look at this contactor, we have here 13 and 14. That one is normally open. Then 23 and 21 and 22 normally closed. So this contactor here is going to get from the normally closed of the neighbor, which is this one. Then that normally closed is going to get from its push button. So that is it. As well as this one is going to get from the normally closed of this one. Like that. Then this normally closed is going to fetch from its push button. Yeah, that is what we call the interlock mechanism. This one was supposed to get from this way, from here. So let's do the naming of our components. So this one is MCCB. Please, this naming more so in software, as it is essential, because it uses these names or addresses to know what device is what. That one MCCB, this one, that one can, this one can be KM1 or KM forward, this one KM reverse, like that. This one, this is our forward switch. This one is our reverse switch. This one is our stop. Then this one is our emergency. I think this one can be our thermal overload. Then down there is a motor to remain as a motor. So I will give our contactors a neutral. That is, I can get from here, I supply our friend here. Then I will consider now the overload. Normally, if I enlarge this one, we use the normally closed, which is 95 and 96. So which is here, 96 is somewhere here. Then from there we get from 95 there, like that. So when we try to run this one, we play here run. When you click here start or first power on the breaker, when you click this one, you see the motor is running in clockwise, but when you release, the motor stops. When you click and release, the motor runs and stops. The same as this one, it goes in reverse direction and clockwise, but when you release it stops. But we need to press, even though we have released, the motor should continue running. So there we also employ what we call self-holding or latching, and that one happens, we connect this switch parallel to 13 and 14 of this one, then this and clockwise switch we connect it also in parallel with 13 and 14. That's the normal open lines with its respective contactor. Thanks. So now we are going to get the power from here. We are going to give to the normally opens, that we're going to use 14. Let me try to zoom a bit. We have here 14, 13, as well as 14, 13. They are normally open. So I'm going to get here 14, and connect it around here. I see. Then this one means it can be connected to pin 3 or to pin 2 of the stop. This very power, I will take it to this respective one. I don't want to try to overlap the cables, so it is coming, it goes to 14 as well as here to 14. Then from 13 it's going to come to its respective coils. So we have here 13 around here. Let me zoom. You see we have here 13 as well as here 13. So we shall get here from 13 . and we connect it to its respective A1. Also here from 13 we connect it here, it is respective A1. I see. But here you may think that these cables are joining these terminals. No, actually they are not joining. For a joining, we have this, that joining, that is in electrical installation, that symbol means the cables are connecting each other. I think with that simple explanation I'm done with the circuit. So let's try to play and we see the products, what it produces. So now here this is simulation start. When I power on the breaker, so when I press my forward button clockwise, you see this motor is running clockwise. I've released but the motor is still running, so it is latched, self-held. Even though, so now the interlock, even though I switch on the reverse direction, this motor is not supposed, this contactor is not supposed to power on, since this one is still on. That is the interlock. We did it by first this contactor first passed through the normally closed of this one to power this one. Then this one also passed through the normally closed of this one, the forward, to power the reverse. If you followed critically, I think you should be well versed with that one. So when you press stop, it goes off. Then when you clock or anti-clockwise, the motor is running in anti-clockwise direction. Stop. So that is a simple circuit how we go about by reverse and forward and reverse clockwise and anti-clockwise rotation of a 3-phase induction motor.